Good afternoon, everyone, and welcome to today's webinar, Unleashing the Power of Artificial Intelligence, Exploring the Capabilities of ARDI. I'm Lauren, and I will be guiding you through today's discussion. At III, we partner with Optrix to bring you a cutting-edge platform that leverages the power of artificial intelligence to transform industrial processes. Optrix excels in creating software and hardware solutions for smarter operations in industries. Together, we bring you ARDI, Asset Relationship and Data Integrator, which provides more than just traditional data integration. With ARDI, powered by advanced AI algorithms, we offer a transformative approach to assessing, analysing, and using your data. Through immersive simulations and advanced augmented reality, we provide unique insights into your facilities, unlocking new levels of efficiency and productivity. So before we begin, let me introduce you to our speakers. We have Aston Bell, our Technology Solutions Manager at III, and Stephen Harding, the ARDI Solutions Architect from Optrix. Both Aston and Stephen are experts in developing innovative solutions for industrial challenges and will share valuable insights with us today. Together, they will guide us through an exploration of AI-driven solutions focusing on the transformative potential of ARDI technology in AI and analytics. If you have any questions, feel free to send them through the chat. We'll have a Q&A session at the end. So let's get started. Aston and Stephen, over to you.
Thank you, Lauren, and good afternoon, everyone. Thank you very much for all taking the time out of your working day and joining us on this really interesting and at times very intriguing topic that we all often hear so much about. To us, this is something that we see as an opportunity for you to help create further competitive edge in today's data-driven, rapidly evolving marketplace. Okay, so AI, what really is it and why can it be a good thing for us? And we'll get into a little bit more about that shortly. Why are we doing this seminar? And I think it's really important to sort of understand our motivation as much as yours for joining us today. Well, it's pretty simple. There's a lot of information out there and we felt it's our duty to help share, educate, and understand the value and the transformative potential this technology can provide you. We want to offer some insight and examples of how I can help you and in your operations every day, each day. But most importantly, we're hoping it will inspire you to explore further in your business operations and take advantage of the opportunities to potentially leverage AI-driven technology in your business. So let me digress for a little moment to touch on III and who we are. We've been around 37 years now, established back in 1986 by our Managing Director, Gary Harding. We have 90 plus staff and we are a truly integrated engineering services company and systems integrator, comprising of 3 dedicated divisions, our engineering technology group, of which I'm part of, electrical and construct, our mechanical and construct, and our asset services and support division. It'd be remiss of me not to point out that we've been working with our partners and Stephen is joining us today on this call from Optrix and the ARDI software platform for several years, helping develop and deliver that capability, which has seen us deploy ARDI for some well-known customers now on 3 different continents, which we're all really very proud of. So why and the what? What is AI anyway? So why now? Is AI just another buzzword and we see plenty of those in our time? Are we doing AI ready? Is a good question. What else can we do with AI? How do we even begin in making use of AI happen? And I'm sure you're like all of us and everyone, we're scratching our heads, because the reality is we don't know what we don't know, and that's part of our motivation for delivering this session today. So artificial intelligence means many things to many people and how it could be applied or used. And typically these systems are designed to learn from data, recognize patterns, make decisions, solve problems, I guess is what we're all looking for. And interestingly, for those who are not aware, artificial intelligence is a stream of computer science that has been focused on creating systems that can perform tasks typically required human intelligence. But by the way, artificial intelligence isn't new to the process industry for those who have been around a while. In fact, it's been used since the beginning of process automation. So you might want to just have a think about that. My colleague Stephen will touch on some of this shortly, and some of the other benefits and values that really include what task could it perform for us to free up our human expertise or our human capital on other strategic activities in our business. How are we going to analyse the volumes of data that we've got, and can ARDI provide that capability, further capability for us, particularly in today's data-driven decision-making processes. And last but not least, it's again, how can we apply ARDI to help us optimize operations and help us with things such as enhancing quality of products we may be producing, enhancing safety protocols, and most importantly, where can it help us drive efficiency gains within our operations and our facilities? It's been really interesting to speak to people when the topic is raised, and naturally there's a lot of apprehension, concern, understandably, and even lack of understanding. But there's also often quite some excitement about how do we make this happen? Where can we start? Where do we begin? Some people out there also believe that AI will and can make all the decisions for them. Not necessarily recommending that approach, but Stephen again will touch on some of that as he goes through some examples later. So our call to action is pretty simple. It's to be able to share and educate and communicate and energize you in understanding more about this topic, and even consider embarking on identifying some initiatives in your business and taking some actions to help your company move forward that benefit them across the operations and you and your role and your functions as well. Within a data-driven approach, we also hope to help, as part of this session, help you navigate and understand the challenges between the information being generated in your organisation and better identifying and understanding where value improvement may be gained. So without further ado, it's my pleasure to hand over to a bit more of a dive into the topic to my colleague and co-presenter on the session this afternoon, Stephen Harding, to take you on a more of an insightful journey, AI journey, and we hope you really take something away from this and something interesting that you'd like to expand on a little bit further. Stephen, with that said, I'll hand over to you.
All right, so yes, we're just going to cover what AI is to start with, because there is a lot of confusion about that, and we'll follow up on actual applications in industry and seeing how it can help. So the fundamental, what is AI? Most of you should understand at this point that it does stand for artificial intelligence, but it's actually a very broad term. So technically speaking, any system that makes a decision about data can be considered an AI. So temperature alarms, the warning lights in your vehicle, those are artificial intelligence. Very simple, but they are AI. So this sort of AI that depends on strict rules to operate, such as most control systems, are often called rules-based, narrow or weak AI. Today we're here to talk about machine learning, which is known as strong AI. So these, rather than being built up of human-written logic and rules, are trained. So by exposing them to real-world data, they learn in their own unique way the correct responses to that data. They can be very, very useful when you want to improve key decisions about how you want to respond to a dynamic analog world. Just to be clear, though, the robots are not coming to take over. Although AI professionals call rules-based AI weak, it doesn't mean it's actually inferior. There's always going to be a place for rules-based logic and process control. But machine learning can help refine some of these key decisions around your process, the AI usually working with the constraints of your logic, not replacing it. Along with pretty much every website on the internet, machine learning has been making its way onto industrial sites, but often at what we call the corporate timescale, where you've got a cloud-based solution looking for failures in assets over very large time spans, like months or years. These are useful, but these sorts of asset intelligence platforms are far removed from the factory floor, where decisions are made in seconds rather than days. There's still a huge number of undiscovered opportunities in using machine learning on this sort of high-speed process data to make AI work in applications where you need insight now. But once we do have AI at this sort of time scale, what can we do with it? When it comes to process systems, there's a few common goals that almost all of our customers seem to share. Saving energy, reducing carbon and waste, minimizing downtime, and maximizing utilization are all front of mind, meaning people are hunting for the opportunity to improve their processes and achieve these outcomes. But finding these areas of improvement and realizing these improvements is getting harder. So most sites have catered for the obvious impacts on performance of energy use. And here's where machine learning really shines, when your problem starts becoming extremely complex. We're going to actually walk you through a little example of where machine learning takes over. We're going to be cooking. We're going to bake cupcakes in an automated system. We've done some test runs, we've had a look at our results, and we're going to try and figure out the best way to run our machine. Here's a little chart of our success versus our oven temperature. So our green dots are good results, red dots, not so great. At the moment, they're pretty scattered, but we do find that if we keep our oven temperature within this band, we get good quality cupcakes. But what about here? So we're getting some good results. That indicates there's potential there. Can we dive in and find out a little bit more? Is there some potential improvement? By taking our problem and adding another dimension, so in this case, we're going to add the speed of our conveyor belt that runs our cupcakes past the oven, we can actually see that, yes, there is a trend line here. There is a lovely fit. That means that by catering for conveyor belt speed in our logic, we'll be able to improve. We've discovered that there are opportunities in either reducing our line speed, reducing our temperature and saving energy, or increasing our line speed and producing more. Either way, we manage to maintain our quality. And adding dimensions to a problem like this, what's often called the problem space in AI terms, we'll often find these new paths to value. But we've got this little outlier here, one bad result. Can we do something about it? Well, we'll do the same thing we just did. We'll add another axis. In this case, pulling a random attribute out of a hat, we're going to add ambient humidity. We've now pulled our problem into a 4-dimensional space. And here we can see that, yes, okay, that is definitely a potential cause of the problem. But it's starting to get a little bit difficult to understand the graph. This might explain the problem, so ambient humidity could be the cause, but how do we know? How are we supposed to go through all the different possible combinations? And even if we do manage that, how can we write the logic for a problem that is so complex we can't actually graph it? It's difficult because we've reached the limit of what the human mind can visualize. But the key word here is human. AI can produce results even when there's hundreds or thousands of different factors to consider. AI models can deal with a level of complexity that's literally unimaginable and can still answer questions in moments. So let's take a quick look at a couple of related examples of how machine learning can help with process systems. When you're running a process, you have to decide on the tolerances and set points and the limits across your system. Alarm limits in particular are often set fairly loosely. The maximums and minimums for your alerts will be set based on the worst case scenario. Like here, where we're measuring the color of our cupcakes and only alarming on the lightest of raw dough and actively burnt. What if we could tailor our limits? What if we could use machine learning to make these limits adaptive so that they're tailored specifically for the different products and setups and machine modes or even ambient operating conditions? Here we can see a color of a failed batch of cupcakes. And here's our set of control limits that we established earlier. We'll notice that the alert happens right at the bottom here once it's actually already too late and burnt. Whereas if we have a more adaptive approach, if we have a set point that takes everything into account, we get tolerances that allow us to alert significantly sooner. So not only are the alert set points tailored for the current system state, they're based on real examples and not somebody's assumption of what should happen. They appear before we reach those extreme values, and they happen sooner where we might still be able to take corrective action. And as a nice bonus with AI, when you apply these things to a new product that has never been used before, done before, there is a chance that it'll be able to actually predict the correct set points just because of its similarity with other things. We don't need to update and upgrade our alerts one by one, though. We've been experimenting with using machine learning to make simple system models, so digital versions of your assets that are trained using your history. These aren't as advanced and aren't as capable as genuine system models, but those sorts of models take an enormous amount of effort to create. These instead can be used to predict how your system should behave in normal operation. So, for example, if we wanted to make a simple twin of our conveyor motor, we could get all of our historical data together and we build a predictive model, which basically tells us, yes, given all of this system state, we should be doing this. If we run this model live, so it's constantly up to date, we can compare the live values with what we're getting out of the model, which gives us immediate indication of when there's a discontinuity, when something is acting abnormally. This lets us, with one step, create a suite of different alerts telling you when every measurement you're making might be out of spec. So what are AI models and how do we build one? So we're going to get into some of the technical side of how to build them and what they are. So an AI model is an AI built to solve a problem. Now you'll need a few things to build one. Each model has one or more inputs. So these represent the different observations a model can make, such as the pressures, the temperatures, the current recipe. They're the way it sees your problem. They also have one or more outputs. These represent the answers to the question you might have. A key thing here is that all of your inputs and all of your outputs are numeric. So machine learning models can't deal directly with text. Even ChatGPT has to convert everything to and from a numerical representation. So using the example from earlier, we might want to create an AI model to estimate the ideal oven temperature for a specific speed, humidity, and type of filling in our cupcakes. Obviously, oven temperature is going to be our output, and we can add any of our available data points as inputs to the model. One of the nice things here is that AI doesn't make assumptions. We can throw any number of inputs at the AI and it will determine which points are useful and which are useless. Because we do find in the real world occasionally an engineer will make what sounds like a perfectly reasonable assumption that A and B are unrelated. But every now and then, that's not right. Because AI doesn't come in assuming the things are not going to be related, it can sometimes find these subtle but still important relationships. After the inputs and the outputs, you're going to need training data. So AI usually hates missing data if you have gaps in it. So it's very important that you basically have clean training data. It's also important to have quite a bit of it. So if your machines operate differently, so you do different types of products or different types of cupcake in this case, you'll want training examples from a variety of different recipes. In some cases, if you're trying to make something that's telling you if you have a particular problem, so as a detector or a classifier AI, you'll need examples of the problem, but you'll also need examples of the opposite, of not the problem. And there can be actually quite a few different examples of not the problem you'll need to give it. And of course, things don't always happen the same way twice. So having a number of examples of the issues you're asking it to look for is very important, because that way it actually learns what the key signatures are, the common elements are, rather than just identifying that one specific problem. The last thing we need as part of an AI is the technical part, the algorithms and the tuning. So there's a number of different options when it comes to the type of machine learning algorithm you use and the parameters, which they call hyperparameters, just to sound exotic, that you give it. It's very technical. We're not going to deep dive into it here. But the main thing and why it's so big now all of a sudden is that in the last few years, there's been massive improvements in how easy it is to create machine learning solutions. Improvements in hardware, significant improvements in software, and the availability of open source and community-driven tools. Getting your AI accurate does have a tuning process that's part art, part science. Even experts will usually fall back on a certain amount of trial and error to find the right combination of parameters to suit a particular problem. It's not that different from tuning a control loop. You've just got a few more levers to play with. But there are luckily some sort of go-to setups for common types of problems, specifically and especially in the industrial market. These sorts of problems do fall into a few different categories. So classification questions ask, is this thing in this condition? So is a machine slow? Is it failing? Is it unbalanced? Is it operating normally? These don't do simple yes or no answers that you traditionally get from your rules-based logic. These will give you a confidence level output. So you'll have an analog value describing how close it feels you are to the conditions you're looking for. With most AIs, you can also attempt to make predictive models to actually figure out it's going to be in this state a certain amount of time before it does. These aren't always possible, but when they are spectacularly useful. There are also value modeling questions. So what should the value of X be if all these particular conditions are met? We've seen this in our bakery example. So trying to find the best value for oven temperature given all these other factors. They can also be used predictively to try and forecast what a demand is going to be, or forecast what we're going to need in a hopper for a particular task. Or you can use them as virtual sensors. So a common one is somebody's making a manual measurement fairly routinely. You can use AI to then take those results and build a virtual online sensor. Machine learning systems also include what are called novelty detectors. So this lets you say if a particular machine is acting, quote, normally or not. They're easy to train and quick to run, and you can capture a huge range of potential issues and, in some cases, potential improvements, because abnormal isn't always negative. The key advantages when it comes to machine learning, they deal with extremely complex multidimensional problems. They don't need to be given rules. They just actually are exposed to data and figure it out themselves. They're never blinded by assumptions and opinions. Once trained, they're incredibly fast. They can estimate results when exposed to new situations, although there's a flip side to that particular coin. And they can uncover unexpected, subtle, and almost imperceptible interactions in your data. But I'm not lying to you here, so we are being honest. There are downsides. Machine learning models, they only answer the question they're specifically designed to answer. So if you want a new question, sometimes even only a subtly new question, you have to build a new model. They're not reversible. So a model that takes A and calculates B can't take B and calculate A. There are some engineering ways you can try and get around it, but they just don't work in reverse. A lot of AI methods can't explain why they reach the answers they provide. So if you want to know why that alarm is going off, in certain cases, it just can't tell you. It knows something is wrong, but any more is a bit beyond it. If they're being exposed to something that's way outside what it's trained in, they can be very confident about completely rubbish results. And most people will be able to experience that in ChatGPT. If you ask a very particular, specific question on a technical subject, it will start very confidently spouting complete garbage. And unfortunately, machine learning, it can happen. They can be pretty expensive in terms of computing power to train. They run with much less cost, but even then, if you are using large numbers of them, there is a computing cost to it that's a hell of a lot more than your traditional on or off rules. And they can be unpredictable. So until you've actually tested a set of inputs, you can't be 100% sure what the AI is going to respond with. They're incredibly repeatable. They will always give you the same results to the same inputs, but every now and then they will make an unexpected conclusion or have a connection that you don't anticipate. So yeah, when you're wandering outside the usual area where you use them, you can take things with a grain of salt until you've verified them. All right, quick break. We've now discovered what AI is. So we're going to introduce you to ARDI and look at some of the ways that it actually helps get you to being able to use machine learning powered solutions in an industrial environment. So we had a look at what a machine learning model needs, and we're going to go through how ARDI addresses some of those needs. But the first thing you will need is a complex problem. And we do really mean that. If you can easily write a rule to solve the problem, do it. Using machine learning to solve a problem that's easily solved using math, it's a waste of time and computing power. We need the things we've covered before, the inputs, the feedback, and the training data. But also we do need a last step that's often ignored, even during digital transformations, is how are we actually going to use it? ARDI helps you at various steps on the journey. When it comes to the question, we can't actually provide the question itself. That's up to your application. But we can provide a range of pre-made solutions and advice for certain styles of questions. So we have tools, we have user interfaces, we have builders, we have a variety of different things to help you go from, oh, I'd like to make an AI about this, to actually being able to build it. To help deal with some of the complexity of the system itself, we try to, wherever possible, give a system a sensible human readable structure. So for those who haven't done it already, we take the giant data lake full of completely unrelated points and turn them into assets, each of which have types, properties, media, and relationships with one another. And these assets don't have to be equipment. So departments and sections, recipes, even your human resources can be assets in ARDI. ARDI fundamentally is a data consolidation system. So it brings together a number of different sources of information in one place. This is huge when you're trying to build up the inputs to your AI. It's not another database or historian, so we don't record data, we don't replicate anything that's not necessary, and we don't replace any of your existing systems. We sit between the tools you already have, acting as a central point where you can get access to the information easily and consistently from a variety of different sources at the same time. This includes sources from information from different timescales, different departments, and different levels of your network. Since the system that records your sensor values isn't often used to store maintenance information or production schedules or your planned outage calendar or your staff roster. When you connect all of these to ARDI, the information you need to build a data-driven solution is all in one place. It's available without needing to know the details of where it's stored or what it's called. It's accessible without needing to understand multiple different products and different access methods. It's human readable in a logical structure. And it's provided without replicating data, which means not only does ARDI have a small footprint, we're particularly useful when you're dealing with data that's subject to change. So data that's in the future in particular, your plans, your forecasts, these things evolve. If you're replicating that data, It's a nightmare, but because ARDI goes to the original source of the data and always pulls the latest information, the future is easy. ARDI can also be given details. I mentioned relationships and just previously. It can be given details about how your assets are connected. So where they get their power, where they get their water or other signals from. Among some of the big advantages of that is that in our query language, we actually have an individual function that says, please give me all of the points that you believe might be relevant if I'm going to build an AI. One single command and it returns dozens of points from multiple different assets and multiple different data sources to help you get started on the AI journey. Outputs are quite similar to inputs, but this is where it's useful for ARDI to connect to a range of non-traditional data sources. So if you're trying to improve quality, you're going to need some feedback letting you know the results of your quality tests. Some industries are lucky enough to have these using live sensors, but a bunch of others are still using human help and human-assisted steps. The information they generate is usually not stored in the same place as the live status. It's usually out of phase or inconsistently timed, and often it's stored in a format that's awkward to use. It's in an Excel spreadsheet or it's in a strange location. ARDI helps you deal with all of this, and it lets you synchronize, transform, and collect the lags in your data. We've got a library of different drivers for very common data sources and industrial historians, etc. But we know it's impossible for us to support every different source of data and every different workflow you might use. So we give you the ability to create your own drivers that access your own unique data sources, or edit our drivers to make them suit your needs more. This means that the feedback data you're getting from manual observations in Excel spreadsheets or stored inside DXF files or PDF forms is just as accessible to you as the data in your SCADA system or your SQL database. Most machine learning techniques do really struggle with empty data, but the real world isn't synchronized. You've got dozens, hundreds of different channels of data being recorded at different times, some updating every hundredths of a second, some every day. ARDI can create tables of data that have values for every point in time, unless specific points were genuinely offline. So these tables are great for use in AI models, but they're also very useful for Excel, for analytics, for doing anything where you actually want to make sure you have a complete set of data. It deals with all the differences between time zones, date formats, sample rates, and also the nature of the data points. So if something is a digital signal, it deals with it differently to how it would deal with an analog signal. We also deal with inconsistencies between data sources, because you will often find that doing something on data source A will give you a slightly different result to doing something on data source B. We help abstract all that out. And we deliver metadata. So for every property you have, we can give you a little bit of extra context so you know how to prepare it and normalize it or standardize it for use in AI. And most importantly, we abstract the data. So when change comes, and change is always going to eventually come to your process. If you upgrade equipment, if you completely replace your whole data backend, you can remap that in ARDI. And as long as you have the same actual measurements taking place, your AI continues to run, even if the data is from a totally different source. This means that not only is your one site robust against change, it also means if you want to move an AI between sites, as long as your machinery is very consistent, that won't be a problem. And one other thing that's important is ARDI isn't just for consolidating information. We also focus on distributing it. We can do summary reporting, sending your daily or monthly or weekly totals up to management, But we've got a deliberate focus on getting information into the hands of other people across the organization, to technicians in the field with augmented reality, to operators with 3D interactive visualizations, to anybody who cares about it really with dashboards and displays, and even people who aren't on site at all with interactive photography, which is our version of Street View, where you can touch and interact with the equipment. We provide a number of tools to help you send your AI results to where you need them to go, be them human or other systems. And this all makes it easy to help people actually start engaging with the results of your AI, be it an alert or an analog signal. It's really easy to get it into the hands and minds and data streams of the people and things who need it. Some just little important things that come up. So ARDI is not a cloud-based service. It's on premises. You put it as close to your historian as you can in most cases, so you can use live data efficiently. You can even run it on something as simple as an embedded system or a Raspberry Pi, all the way up to cloud servers. It doesn't tie you to any particular AI platform. You can use open source tools like PyTorch or TensorFlow for your AI, or proprietary cloud-based systems like those from Azure or Amazon. You can build something entirely in-house. We do not restrict anything. And since ARDI has live data, it also does help you run your models live. So you get instantaneous or very, very fast feedback when process conditions change. You can push those values that you're generating out with OPC-UA, which means you can actually integrate your AI with your process system or with your SCADA system, so you can actually use these results. So it's still early days for using machine learning down at the high-speed process level. We've shown a few examples of how it can add value and refine your control and alarm logic, but the pace of progress is still intense. We don't know where the journey will end. We can already see the value. It's not something you have to wait for. The tech actually does exist now. It's not something to fear. Your existing logic remains in place. It only helps smooth out and optimize those values that will tend to change naturally. And it's not black magic. With training, anyone can do it in-house. And using the right platform, you'll be ready for it. With ARDI, we were always designed to be built on, to be open enough that people have their process information ready for the next big data-driven thing. We originally built it with VR and 3D in mind. We made sure it was flexible enough that it could be used for other things, which is why we have reporting and analytics and augmented reality. These all just came out of the fact that it was a platform. Now that a new wave of machine learning solutions has arrived, we've found that not only is ARDI ready, it's an amazing fit. We've always been here to help our customers break down the barriers between the data, the opportunities for value that's hiding inside it, and the people who are integral to unlocking it. But now with machine learning, when we push up against the limits of what's humanly possible, we can now offer the tools to go beyond.
Thank you, Aston and Stephen, for your insightful presentations and sparking further discussion. As key takeaways, consider the following. AI has this transformative potential for businesses, optimizing operations, resource management, and customer experiences. Embracing AI provides a competitive edge in today's data-driven landscape. And most importantly, attendees are encouraged to delve deeper through discovery discussions or workshops with us on unlocking ideas and addressing challenges. Explore how AI, especially with ARDI, can benefit your business and operations. We are now moving into the Q&A segment of our webinar. We've received some excellent questions via the chat. If you have any additional questions, please keep sending them through. Stephen and Aston, are you ready?
Sure, hit me. Just don't ask about ChatGPT.
Yeah. Okay, so the first one, are there any AI-driven features within ARDI that enable automated decision-making or predictive maintenance?
All right, so as we've seen the output of an AI, or especially a machine learning model, is just a set of numbers. So you've got to perform some logic. It could be a simple comparison or something fancy like linear optimization to turn those into a decision. But because ARDI doesn't have the ability to write, so for security reasons, we cannot write to anything we're connected to, ARDI won't be making that decision for you. Plus also, at the purely operational level, there's so many different types of decision at so many different timescales that making a generic solution to do it for you out of the box would be a true nightmare. So while ARDI does help bring the AI to life, we value flexibility a lot. So a product that has pre-built decision-making will usually limit you in what decisions you can make and forces you to adapt to the way it does things. With ARDI, we try to be flexible enough that you can integrate ARDI data into your existing decision-making workflow and deliver the information to the people or the systems that actually make the decisions. So short answer, too long, didn't listen, is we make it extremely easy for you to make a decision-making system with your data.
The next question. So are there any future developments or enhancements planned for ARDI's AI functionality?
More or less constantly. The beauty of the industry being so fast moving at the moment is there is always a new algorithm, a new solution. Because of the fact that it is full of garbage a lot of the time, ChatGPT, for example, we will not use it for anything but generating text. But some of the ideas behind ChatGPT have been extremely useful in making models of process systems. So, and as well as that, we're looking at the ability to push AIs out across a cluster of computers or even hybrid solutions where some AIs are running locally and some AIs are running in the cloud, all governed from a central ARDI server. There's plenty of space for changes, improvements, and entirely new ideas.
How customizable is ARDI to specific industry needs and data formats?
So flexibility is one of the key watchwords of ARDI. It's always been key to the design. So we've deliberately worked with a wide variety of industries to make sure that it is a platform that can work across a large range of applications. We're open so that we can be adapted to a variety of unusual data sources. When you build an ARDI system, you choose what assets, what properties, what relationships are relevant to you and your users. So, we're not limited to any particular industry. And to be honest, we're not even limited to industry at all. It could be used in commercial environments, maintenance, shipping and logistics, or even healthcare. But the people who have pain with very high-speed data tend to be in the industrial market, which is where our focus has been.
Lastly, what kind of training or expertise is required for organizations to effectively use ARDI?
So we do have online training and we do offer formal training either in the product suite as a whole or on specific areas of the product. One thing we will usually do if we do have a multi-day training session set up is ask our trainees to bring an application they're familiar with to us, and we'll guide them through the process of actually building their first system and making the decisions based on a thing that they're used to and they understand well. We do find that sort of interactive, bringing it back down to concepts they know and understand well is extremely effective. And also, all of our license holders do get web-based support included with their license, so we're more than happy to discuss applications when people are wondering, how should I, or is there a guidance for doing this? More than happy to help.
So this brings us to the end of today's webinar. Thank you all for your participation and engagement. Keep an eye out in your inbox as we'll be sending a follow-up email shortly. If you'd like to delve deeper into any of the topics covered today or have further questions, please don't hesitate to reach out. You can find our contact details on the screen or visit our website at www.triplei.com.au. Aston is available for a chat. You can reach out to myself and I'll connect you with him. Once again, thank you for joining us, and we look forward to continuing this conversation in the future. Have a great afternoon.